Today we continue with the topic on coastal littoral processes. Here we have a series of diagrams showing how a dune can evolve um, and also how eroded sediment from the dune can be deposited on its lee side. We have mentioned much about the dune for some time. This is what a dune looks like. Basically, they are the vegetated uh, backshore region which can effectively trap further movement of the sand or the sediment. Of course, as we go further landward, then the dune are overgrown not only by grass but by shrubs and forest. So basically, the dune is the last line of defense in the coastal littoral transport, and rarely will we see the sediment transported further landward from the dune system. Wind transport plays an important role in dune formation. It carries the sand or sediment material in the foreshore area to the backshore, where these material are stocked or stored, because this is where the landward limit of the littoral process is located. As a result of that, the sediment stored in the dune acts like a reservoir or a stockpile, ready to re-nourish the beach. So during a storm event, the dune will be eroded. It will lose its material, but basically it lost its material back to its own beach, back to the sea area where the littoral processes is active. But over time, it can be as short as days or weeks or longer, this material will be able to help the beach to be restored to its original equilibrium condition. And of course, eventually the sediment on the foreshore area will again be brought back to form the dune system, and the process repeats itself. So essentially, the dune system plays a very important part of the dynamic equilibrium of the coastal littoral processes. This figure here shows the typical profile of a foredune, which is shaped by the obstruction to sand transport, such as vegetation, as we just mentioned. On the beach itself, the seaward part of the dune system typically is shaped by water level and waves, whereas beyond the crest, it is shaped by any overtop water that flows in the lee side. Sediment response to wind can be classified into three types, which includes saltation, surface creep, and suspension. Saltation is the primary mode of sediment movement under wind action, which can make up to 80% of the sediment transport. It involves dislocation of the sediment from its original surface so that it moves upwards in an arc before falling back to the uh, ground surface again. The sediments that falls back on the surface may actually undergo saltation again, or it may dislodge or move other sediments into saltation. Surface creep, meanwhile, is usually less than 25% of the sediment movement. It involves sliding and rolling of sand particles on the surface. Usually, this applies to larger grain size, whereby the grains never leave the ground surface, but still they are able to move under the action of the wind. Suspension is usually in negligible volume. It involves much finer sand particles, which can be lifted up by the air turbulence and transported over long distance, and it can even be transported at relatively high altitudes. The threshold of wind velocity on sand transport is limited by grain size distribution, by moisture content on the sand bed, wind vertical velocity profile, wind speed or gustiness, sand bed slope, and the existence of vegetation. Because of the importance of the dune system, assisted fall dune development may be necessary in order to maintain the stability of the sediment in a coastal area. This can be achieved by vegetation planting, especially beach grass, or it can also be achieved by installing this type of semi-porous fencing as shown in order to trap the movement of sand, especially saltation and surface creep, which can be limited by height. Of course, if it is necessary to rebuild the dune as fast as possible, then earth moving or earthwork may be necessary.